Hello everyone, my name is Iris Franz. Today we're going to talk about extensive form games. An extensive form game is a game in which players move in sequence. Therefore, an extensive form game is also known as a sequential game. For example, chess is an extensive form game where one player moves after the other player moves. You can draw a game tree for an extensive form game. Let's look at an example, the entry game. In this game, we have two players, the new firm, N, and the existing monopolist, M. So here's a story. In a small town, there is only one monopolist, M. The new firm, N, is deciding whether it should enter the market to compete with the existing monopolist, M. Note that at the end node of each branch of the game tree, you see the payoff to each player given that the node is reached. The first entry in green is a payoff to the first mover, N. The second entry in purple is a payoff to the second mover, M. Here, N is the first mover. If N chooses to stay out of the market, then the game ends. And the payoff is $0 for the new firm and $10 million for the existing monopolist. If N chooses to enter the market, then M will choose to either play mean or nice. If M chooses to be mean, then it starts a price war. As a result, both the new firm and the existing monopolist will suffer a loss. Specifically, the new firm suffers a $2 million loss, and the existing monopolist suffers a $1 million loss. If M chooses to be nice and shares the market, then N will get $2 million profit, and M will get a $5 million profit. How do we solve for Nash equilibrium of this game? We can draw a payoff matrix to solve. In the payoff matrix, the new firm is the row player, and the existing monopolist is the column player. If the new firm chooses to stay out, then we are on the top row. In that case, the payoff will be $0 for N and $10 million for M, regardless of what M chooses. Therefore, given that we're on the top row, the existing monopolist will be indifferent between mean and nice. Hence, we underline both payoffs to the monopolist. That is, we underline the $10 million under both strategies, mean and nice. However, if N chooses to enter the market, then we are at the bottom row. In this case, if M chooses to be mean, then M will suffer a loss of $1 million. If M chooses to be nice, then M gets a payoff of $5 million. As $5 million is better than negative $1 million, given that N enters, M will choose to be nice. We underline the payoff $5 million for M. Let's now solve the problem for the new firm. If M chooses to be mean, then for the new firm, it is better not to enter, as $0 payoff is better than negative $2 million. We underline the $0 payoff for the new firm. If M chooses to be nice, then for the new firm, it is better to enter, as $2 million payoff is better than $0. We underline the payoff $2 million for the new firm. Notice that double underline in a cell indicates mutual best response. Therefore, we have two Nash equilibria. That is, the new firm stays out and the monopolist plays mean, and the new firm enters and the monopolist plays nice. There are two things to notice here. First, a Nash equilibrium is a pair of strategies of the two players, not the payoff. Second, one of these two equilibria does not make sense. Now hit pause and think about which of these two equilibria does not make sense. If the new firm has already entered the market and you, the monopolist, chooses to be mean, then you get negative $1 million. If you choose to be nice, then you get $5 million. $5 million is better than negative $1 million. So, the monopolist would choose to be nice. In fact, as a monopolist, you will never choose to be mean. Being mean is shooting one's own foot. We economists call this a non-credible threat. Therefore, Stay out, mean, is a Nash equilibrium that does not make sense. We know that the monopolist would never choose to be mean. We can use backward induction to refine Nash equilibrium to subgame perfect equilibrium. That way, we can eliminate non-credible set. What is backward induction? It is solving the extensive form game from the end to the beginning. So, we will start from the end node of the game. Suppose we're at the last subgame, that is, the new firm has already entered the market. What would the monopolist do? It would choose to be nice, as $5 million is better than negative $1 million. Therefore, we can do some trimming, getting rid of the branch that the monopolist will not choose. Next, we consider the new firm's movement to stay out or to enter. Now, N knows that the monopolist will never choose to be mean, as the mean branch has already been trimmed, and that's not where we're going to. The new firm would think, if I stay out, I get $0. But if I enter, I get $2 million. $2 million is better than zero, so the new firm would choose to enter the market. We call this the subgame perfect equilibrium, where the new firm enters the market and the existing monopolist plays nice. I hope this helps, and I'll see you next time.